All right, so we're going to have a look at this quick question here, which is being asked to sketch this square root function. So let's have a quick read through it and identify some key information. So we've got an a value here of 3, which pleasingly was the same a value we had in the Desmos example, so we know what it's going to look like or what effect it's going to have. We've got a h value here and we've got a k value. All right, so I'm going to write them underneath. We've got, oh, I did it again. I'm writing in that. I've got a equals 3, h equals -1. We have to read it as -1 because it's being the opposite of. All right, and k equals -6. Now I'm going to, underneath that, I'm going to write down the effect that I know it has. So this stretches graph vertically. The h value translates it 1 unit left, -1, and the k value translates 6 units down. Now, the best way to do this is to just identify one point on the graph and translate and stretch that point, and then everything else should fall into place. So the one that we know is on every graph is this origin here at 0, 0. So let's not worry about the stretch just yet. We'll come back to that, but we're going to translate it. So we're going to move it 1 unit left. So bang, it's there. Now 6 units down, we go 1, 2, 3, 4, 5, 6. So it's sitting here now. This is the start of the new graph. All right, so I'm going to label this. This is -1, -6. All right, key point is to always label those coordinates on your graph. Okay, so now we're going to look at the rest of the graph. Now, normally this square root function would sit like that. All right, but we know that this stretch has occurred, and from the Desmos example previous, we know that that stretch looks like this. It's been stretched away from. All right, so we know that this has been moved down to the blue point, and then it's been stretched up and around, so it should look something like that. All right, I've drawn it a bit bigger, but we'll get there. All right, we're going to go through and calculate the points that we need to know. So we'll erase those. The red line is what the graph should look like when we're finished. So the next step then is to calculate the points. All right, so we've got, here's the function. We need to know this y-intercept and this x-intercept. All right, so let's go for it. To find the y-intercept, we set the x value to 0. 0 plus 1 minus 6. 3 root 1 minus 6, which is equal to 3 minus 6, which is equal to -3. All right, so there's this point here. It is at -3, and you can see that the red graph I've drawn quickly to check my work is not really accurate, so I'm going to have to move it. So let's delete that point. We'll make it, where is it? 1, 2, 3. There, so that's the new y-intercept. So then to find the x-intercept, you set y equal to 0. We've got 3 root x plus 1 minus 6. Move the 6 first, so you end up with 6 equals 3 x plus 1. Divide by 3. 2 equals root x plus 1. Square both sides to get rid of the square root, so end up with 4 equals x plus 1. So therefore, x equals 3. So this point here, 1, 2, 3, here is my new x-intercept. So I'll just erase this line here that we put in there, which was in the end not great. We'll redraw the graph, put this point back on, and then we can join up the 3 dots we have in as nice a curve as possible, which is kind of difficult until you get the hang of it. All right, so you've got a pretty straightforward process here. You've got to make sure you identify the changes that have occurred. I wrote the changes, what the effect of the changes was down here, but this is not a step you need to take if you feel confident. I did a quick sketch using these changes, and then I calculated what the exact points were, and the quick sketch was confirmed by the shape of the final graph. All right, so I'm sure you're shouting at the screen right now that I haven't labeled my points, so I'm going to go ahead and label them before I finish. 3, comma 0. And the final step is to label the graph with the equation we used to graph it. All right, so in recap, identify the changes, calculate the points of interest on the graph, quick sketch, and label everything you need. All right, one more example we're going to look at before we finish is a sketch of another graph. So a quick identification of the changes that have occurred. I have an A value here, I have a H value here, and I have a K value there, and I've also got a negative sign. Now I've mentioned it for parabolas and I haven't mentioned it since, but try and think about the A value as always being a positive number. So you only look at the A value as being the digit. This negative is not part of the dilation. It just tells you about a reflection. So we've got reflection. We've got dilation. We've got translation and translation. So this is vertical and this is horizontal. All right, so a quick sketch of our graph would be something along the lines of this. It's been moved 1 unit right and 3 units up. So it starts there. It has been reflected. So instead of going up like this, it's now going to go down like that. And it's been stretched. So instead of looking like the first second blue line I drew, it's going to be slightly further away from this imaginary line there. All right, and this, because that's a bit confusing, I'll erase those things off and I'll erase that out. Okay, so hopefully our information shows us this dotted blue line at the end of the problem. All right, so let's go through and calculate. All right, so we're looking for y-intercept first, and if you've just suddenly realized that this graph doesn't seem to show a y-intercept, then you're on the right path, and hopefully our calculations show that as well. So to find the y-intercept, we set x equal to 0. So we've got minus 2 root 0 minus 1 plus 3, which equals minus 2 root minus 1 plus 3. And at this point, hopefully everyone is now shouting at your screen saying there is no way for us to square root a negative number. So this backs up our picture. We don't have a y-intercept. We can't go past this point. As tempted as you might be, we can't. All right, so no y-intercept. Now let's try and find the x-intercept. So 0 equals minus 2 root x minus 1 plus 3. Move the 3 across. Minus 3 equals minus 2 root x minus 1. Divide by minus 2, so 3 over 2 equals x minus 1. And if in case you're wondering where the negatives disappeared to, I divided a negative by a negative so it became positive. I'm going to square both sides. 9 over 4 equals x minus 1. Add 1 to the left-hand side. I end up with 13 over 4 equals x, which is roughly the same as 3 1/4. Exactly the same as, sorry. So I'll make sure it's in keeping with the scale of my graph. 1, 2, 3, and there's a quarter there. All right, so knowing that there's no y-intercept, I've got this initial starting point and I've got the x-intercept. That's the only thing that I can possibly graph. All right, so I'm going to join up those two dots with a curve. I will erase the original dotted line, which happily enough was roughly what we wanted to do. And you'll see here that I've got now a nice curve, which was pretty much the same as what we originally started with. One step is to make sure you label your points. This was 13 over 4 comma 0, and the equation of the line was minus 2 root x minus 1 plus 3. Now, interestingly, if you remember back to the original example, you might recall that when it's a negative, it's the bottom half of a square root function, and look at what we've drawn, the bottom half of a square root function. The top half, or one that was shown without a negative, would have looked like this. So you can see here how, even though it's classed as a reflection, you can think about it as a top half being the positive half and a bottom half being the negative half, and that's what this negative out the front shows you, whether it's top half or bottom half. To finish off, to recap, make sure you identify the changes that have happened, do a quick sketch to get an idea, then calculations, and hopefully your calculations back up the quick sketch you did at the start, and then the final thing is to label everything before you finish.